Hey everybody, this is 4.5. So today we're going to be talking about multiplicity. So again, multiplicity is when you have multiple of the same factors. And usually you see that when you have an exponent. So again, an exponent tells you how many times you have that factor. Okay, so this would be like x times x minus 3 times x minus 3. So we have a multiplicity. We have multiple x minus 3's. Okay. So we kind of talked about those before when we were graphing polynomials. If you remember, well, first let's plot those x-intercepts. So x-intercepts, again, is what makes these 0. So either x would have to be 0 or x would have to be a positive 3. So we could plot those 2 points at 0 and 3. And then we talked about how if it has a multiplicity of 1, it's going to cross, and if it has a multiplicity of 2, it's going to bounce at that x-intercept. So really, if we have any odd multiplicities, we have crossing, and if we have any even multiplicity, it's going to bounce. So for this, we had like an example like this maybe, where it's going to cross because it has a multiplicity of 1, and then, sorry, it's not a great graph, it's going to bounce at that, at 3 because of the even multiplicity, okay? So let's see how that affects our graphs when we do rational functions, okay? So first off, again, we always need to factor. So on the top, we would have x squared. On the bottom, we'd need to say what multiplies to negative 6 and adds to 1, or negative 1. So you'd probably say, 2 and 3, probably. 2 and 3, and we just need to figure out the signs. So negative 3 and a positive 2, I think that would give us a negative 1. Okay, so that's factored. We'd want to write down our values of discontinuity. So x cannot be negative 2 or 3. Again, those are the things like what x would have to be to have a 0 in the denominator. Okay. And then holes. We don't have any holes here. So we could write dne. So nothing cancels, top and bottom. So that means that both of these are vertical asymptotes. Okay, and we could sketch those and fill in our table. So this is dne, and at 3 it's dne. We could sketch those vertical asymptotes. Sorry, one sec. I think they're going to come in vacuum, so I'm going to go in a different spot. Give me one sec. Okay. Great. Okay, so those vertical asymptotes, we have one at negative 2, and a positive 3. Okay. Horizontal asymptote, again, we'd want to look and compare the degree top and bottom. So here, this is probably the easiest place to see that. So x squared and x squared have the same degree. So then we just look at the leading coefficients. So 1 and 1 would give us y equals 1. So we'll sketch that horizontal asymptote. Okay, like that. And then x-intercepts, again, is what makes the numerator 0. So the only thing that's going to make the top 0 is 0. So 0, 0. And if the x-intercept's 0, 0, that means the y-intercept has got to also be 0, 0. But we could plug that in. We'd get what? 0 squared over 0 plus 2 and 0 minus 3. So 0 over negative 6 or 0. Okay. And so we'll plot that. We'll plot that there, so 0, 0. And the domain, again, goes from negative infinity to negative 2, negative 2 to 3, and then 3 to infinity. Okay, so it looks like we don't have a lot of points so far to be able to help us fill in those, like the graph, what it's going to look like, but you might have a good idea already. But let's see if we can fill in the rest of those points. So again, we're just going to substitute that information. So I'm just trying to plug this in. Okay, so if we plug that in, we plug in negative 3 squared over negative 3, plus 2, and negative 3 minus 3. And sorry, I thought I had this filled in, but anyways, so we'd get what? 9 over negative 1 times negative 6. So 9/6 or 1.5. So we could plot that. So negative 3, 1.5, which would be right here. And then we'll do the same with 6. So we'll have 6 squared over 6 plus 2, and then 6 minus 3. So 36 over 8 times 3, which is 36 over 24. Again, you can use your calculator to this. I just didn't bring a calculator. So here I think we end up getting the same. We get 3/2, which is 1.5. So at 6, it is 1.5. Okay, and then we would graph it. Okay, so one thing we should notice, and we talked about multiplicities again, so we have a multiplicity on top. Again, that's affects our x-intercept. So at that one x-intercept that we have, it has a multiplicity of 2. So it is going to bounce. Okay, so you might be like, well, how do I know if it's going to bounce like this or if it's going to bounce like this? Okay, so one thing you could always make sure is you could plug in another value. You could plug in 1 and see what you get. So here, over here, I'm going to plug in 1. So 1 squared is 1 over 1 plus 2 and 1 minus 3. So we'd end up getting 1 over 3 times negative 2. So that is negative 1/6. So that means that this point has to be below that horizontal asymptote, or the x-axis. Okay, and we know it's going to bounce. So it has to come back down on both sides. Okay. If there is a multiplicity on the bottom, then the ends at the asymptotes are going to go the same direction. So let me give you a quick little sketch right here. So if we have a multiplicity on bottom, so like an even, what's going to happen is when we have that vertical asymptote, it's going to come up to go the same direction. So up, up, or we could have down, down. Okay, so if we look at this one, we do not have a multiplicity of 2, we have a multiplicity of 1. So if we have an odd multiplicity, then they always go opposite directions, like that, or something like that. So this is what would happen here. Since this is going down on the left asymptote, then here it has to start high. And same on the right side. It has to start high because on the opposite side of that vertical asymptote, it's low. All right. Okay, so let's try just a couple more. Okay, I think we'll do 2 and then 1 on the next page. So here this is already factored. So what would be our values of discontinuity? Well, our values of discontinuity would be -3. We cannot use -3. Do we have any holes? No holes. DNE or none, or something like that, okay? If there's no holes, then the value of discontinuity has to be the vertical asymptote. So x is equal to -3. So let's sketch that. So x equals -3. Oops, sorry, I meant to do my dotted lines. There we go. Okay, and we can fill in that at -3, it's DNE, or undefined. Okay. Horizontal asymptote, again, we compare the degrees. So for this one, we have an x squared and an x squared. So they have the same degree top and bottom. So that means we look at the leading coefficients. This would be 2 over 1 or just 2. So y equals 2. Let's sketch that. So y equals 2. Sorry. Perfect. Okay. X-intercepts. Again, what makes the top 0? So here, if we look at this, x has to be +1 or x has to be -4. So 1, 0 and -4, 0. We will plot those points. So 1, 0 and -4, 0. Okay. Y-intercept, again, we get that by plugging in 0 in for x. So maybe I'll do it right here. So we'd have 2, and then 0 minus 1 is just -1. 0 plus 4 is just 4. And 0 plus 3 is just 3. And squared it. Okay? And I would always, when we're squaring, use parentheses, because if you end up having like a negative and you're squaring it, it's important that you have the parentheses. Okay, that's a common mistake on the test that we had. All right, so here we'd have what? -8 over 9, so -8/9. And if you prefer it as a decimal, that is just fine too. So -8/9, or 0, -8/9, sorry. Or again, that's about, I think about 0.9, -0.9. Okay, so we could plot that. 0.9, about right. Oops, it's negative, sorry. So about right here. Okay, and let's fill in what we have. So -8/9. At 1 it's 0, and at -4 it's 0. And then we just have one more at -2. I'm actually, instead of doing -2, I would maybe say, because I think we already have a good idea of what this is going to look like on the right side, so let's maybe change this -2 to be, I don't know, -6. Let's do -6 instead. So make it an audible, or doing -6. So again, we're going to use this equation that we had, and we're going to do 2 times -6 plus 1, and then -6 plus 4, and then -6 plus 3 squared. Again, you can type that whole thing into your calculator. I don't have my calculator, so we're going to try and do this by hand. So 2 times -5 times -2 over -3 squared. So this would be 10 times 2 is 20 over negative 3 squared is 9. So it's just a little over 2. So it's probably 2.2-ish. So we could plot that at negative 6, it's 2.2-ish. Okay, so now I think we have enough that we can connect our dots and have a good idea of what's happening here. So this 2 points have to go together, and they're going to continue going those directions. Okay, getting closer to those horizontal and vertical asymptotes. And then on the left, these points have to connect. So that means somehow these are going to connect, and it's going to connect and keep going as it gets closer to those horizontal and vertical asymptotes. So again, this is where we would have a multiplicity on bottom. So we have x plus 3 squared, which means at negative 3, at that vertical asymptote at negative 3, the lines are going to get closer to each other, and they're going the same direction, so they're both going down. Okay, so again, multiplicities on top means it's going to bounce or cross at the x-intercepts, and multiplicities in the denominator will be like their behaviors at the arrows, like where they're going. Okay, so if there's no multiplicity on bottom, they're going opposite directions, and if there's a multiplicity of even on the bottom, then they go same direction as they leave the graph. Okay, all right, let's see if we can do one more. I just want to talk about this one. So here we have a multiplicity on top, so that's going to bounce. Okay, and if you want to do that one, I have it filled on the notes. If you can check on that if you'd like. Let's do this last example together. So example 4, if you notice there is, well, I guess it's not factored, so we'd maybe want to do that first and see if we have any multiplicities. So what can multiply to 3 and add to 4 would be 3 and 1, so x plus 3 and x plus 1. On the bottom, there is a GCF of x squared, and if we factor that out, we would have x plus 3. So a couple things we can see right away is that we are going to have a whole, and we are going to have a multiplicity in the denominator, an even multiplicity. So that means they're going to go the same direction at that asymptote. Okay, so let's go and write down our values of discontinuity. Again, x cannot be, we have 2 x's, so we're going to have 2 values of discontinuity. It can't be 0, and it can't be negative 3. The negative 3 will be our whole, because the x plus 3 cancels out. So we would plug that in after we cancel, so we'd have x plus 1 over x squared. So for this whole, we would plug in negative 3 plus 1 over, again, make sure you use a parenthesis, negative 3 squared. So that would be negative 2 over 9. So negative 2 ninths, and that's about 0.2, or negative 0.2. Okay, that means if negative 3 is our whole, then that means that the 0 is our vertical asymptote. Okay, so let's sketch that part so far. At negative 3, it's our whole, it's undefined, and at 0, it's undefined. So we'll sketch negative 3, and negative 0.2. So that's maybe about here. And we have our vertical asymptote at, we set it 0. Okay, horizontal asymptote, again, we're going to compare the degrees. Sometimes it's easier to look at it in standard form. So we have a degree of 2 on top and degree of 3 on bottom. So if the bottom's heavy, then it's always 0. So write that down, y equals 0, and we can sketch that. All right, and then x-intercepts, let's do x-intercepts. So x, what makes the top 0 after you cancel out would be -1. So -1, 0. We could plot that right about there. Okay, and then the y-intercept, we plug in 0 for x, so 0 plus 1 over 0 squared. Oh, can't divide by 0, so that's undefined. We already knew that if you would look at this, right? 0 is one of our values of discontinuity. Okay, and then the domain. The domain, this one will go from -infinity to -3, -3 to 0, and 0 to infinity. Okay, it looks like we're kind of missing some points, so maybe let's see if we can fill some of the other stuff in. I guess we already know the x-intercept, -1, 0. So let's plug in 1 and 2 into here. So it's pretty quick. 1 plus 1 over 1 squared, which is just 1, so we'd just get 2. And if we plug 2 in, so 2 plus 1 over 2 squared, which is 4, so 3/4. So let's plot those. 1, 2, and then 2 is 3/4, about right there. Okay, so again, we have to connect these dots. We know for the x-intercepts, there's no multiplicity, so it's going to go through. And they have to get close to those asymptotes. I probably didn't do really great with that one. It has to get a little closer maybe. And then on the right side, again, these two have to connect, so it has to continue going that direction and get closer and closer to that asymptote. Okay, so again, we can see that these go up and up, which makes sense because we have a multiplicity of 2 in the denominator. And again, you can always add extra points, expand your table if needed to find more points to make sure that it matches how you think it should be. Okay, all right, well, if you have any questions, please let me know, and we'll see you later.